Hello students, welcome to Distinction Learning Platform, and in this video we are focusing on a simple machine. And don't forget to like the video, and also don't forget about commenting in the comment section. As well as there is also an important thing that you need to do. In the comment section you find a link. If you click on it, it will take you to the website where you find some other educational videos like now biology, chemistry, mathematics, and many more. All right, so let us begin with simple machine. So what is simple machine? So basically we know that simple machine, this is basically it is a device, okay, or it is a machine that makes it work easier. Okay, so what are we saying? So we are saying simple machine is basically a device. So it is a device. So let's just say a device or a machine, a device that enables to perform work easier. Very simple definition that you need to remember. A simple machine is basically a machine or a device that's going to make work easier. Okay, now these machines that we are talking about, they are of a lot of types. Okay, so but in this video just concentrate on one type of a machine so that we understand the calculation on it and the examination question that can come on this type of a machine. So now, what are those basic type of simple machines that we know? The first type is inclined plane, and it's the one that we focus in this video. Okay, and the other ones are like pulley system, the levers, wheel and axle. All those types of simple machine systems, we'll talk about them. Okay? All right, in other videos. So now let us begin with what is the inclined plane. Okay, inclined plane. Okay, so inclined plane is one of the simple machines that they use in order to lift the heavy weights or load. Okay, we need to understand on that. So the way it looks, okay, so if you look at the inclined plane, the way it looks like this. Okay, so it's going to have different lengths. So this is what we call an inclined plane. So this inclined plane, as you can see, if they want to lift something or an object which is like heavy, the object that is heavy and cannot be lifted by simple human being, basically we are going to use what an inclined plane. But how do you lift? We are going to put like this object. We are going to put it somewhere here. Okay, and we are going to slide it along this distance. Okay, up until it reaches the top. So instead of just lifting it vertically like this, but you are going to slide it so that it can now make that work easier of lifting that object. That's what we call the inclined plane. Okay. Now we need to understand some terminologies that they use under simple machines, or the terms that they use under simple machine. So there are two important terms that they use. Okay, so terms. So let us understand about the terms. Okay, there is what we call effort, and we know the second one is what? Load. Okay, so we need to understand what it means if someone says an effort and when someone says this is the load. Okay, now what is the effort? So effort, basically they say this is the force. Okay, this is the force exerted on an object. Okay, that's what we call effort. So whenever someone is applying force to an object, basically we're going to call that force as what? Effort. So a good example that I can give is this one. If you have this object here, okay, if I try to push this object forward like that using the force of 40 newtons, So as long as I'm getting these 40 newtons and applying to that object, and that force is what we call effort. Okay, so no wonder we just simply say effort is what? Effort is the force applied. So let's just use applied so that you can remember this word, applied to an object. Okay, since it is the force, meaning that it is measured in what? It is measured in newtons. It is measured in newtons. Okay, so you need to take note of that. Okay, so that's what we call effort. So make sure that you try by all means to identify the effort, because if you don't identify the effort in some certain questions, you're not going to be what? Answering in some certain question. It will be very, very difficult for you to answer those questions. All right. So now let us understand again on the load. What is load? So load we are just talking about the weight of an object, or the force that an object exerts to the surrounding. So basically, to make it simple, load is just the weight of an object. So let us just make it simple. I'm going to say load is the weight of an object. Weight of an object. Okay, another scenario. If you have this object like that on this on this surface, okay, and this object is weighing about maybe 400 newtons, okay, and you are applying the force of 50 newtons. So let us try to identify. Then I ask you to say, identify the effort and the load. How can we identify that? As you can see, 50 newtons is the force that I'm applying to this object, and this is what we call effort. Okay, but what about 400 newtons? 400 newtons, it is the weight of an object. Okay, how much that force the object is exerting on the surrounding surface. Okay, that's what we call weight of an object, and basically from that we're going to say this is what we call load. Okay, this is what we call load. So make sure that you know how to identify effort and load, because the formulas that we'll start talking about, they include effort and the load. Okay. Now, since we know these two important things, now let's talk about the formulas that are going to help us to answer some certain questions. So, what are those formulas? So, formulas that they use. So, formulas that they use, we have what we call mechanical advantage. Mechanical. So, let us use red. Mechanical advantage. Let's just say A, mechanical advantage. Okay. So mechanical advantage, it has a certain formula. Okay. Mechanical advantage, it has a certain formula, but for you to remember the formula of the mechanical advantage, always remember this mnemonic that I'm going to give you. Okay. So remember this mnemonic, which is male. Okay, so you need to remember this mnemonic, male. Okay, this will help you to remember the formula for mechanical advantage. So let us write now the formula of mechanical advantage. So the formula for mechanical advantage, as you can see, male, so we're going to use male. So male, which is MA, which is mechanical advantage, which is MA, equals to, this is what L is, load. Then E is what? Effort, which is male. Okay, so mechanical advantage is nothing but equal to load over effort. That's what we call mechanical advantage. No wonder from the definition of mechanical advantage, it talks about the ratio. As long as you are dividing something, this is the ratio. So what is mechanical advantage? Mechanical advantage is the ratio of load to effort. Simple definition of mechanical advantage. So let us try to write that definition. So what is mechanical advantage? We are saying it's a ratio of load to effort. Okay? Then the other important scenario or the other important concept that you need to understand is that mechanical advantage doesn't have units. Remember that ratio doesn't contain units. So mechanical advantage doesn't have what? Units. So no units. So if you find the final answer for mechanical advantage, don't add units. If you add units, basically that would be a wrong answer. Okay, so that's about the mechanical advantage. So we go to velocity ratio. So apart from mechanical advantage, we go to velocity ratio. Okay, so velocity ratio. Okay, so velocity ratio now, we need to follow this formula. So if sometimes, because I've seen students swapping the effort and the load when it comes to velocity ratio formula and mechanical advantage formula, so don't swap. How? Because if you are able to remember this formula, MEL, which stands for mechanical advantage equals to load over effort, it can help you to remember the formula for velocity ratio. So we are going to say, let us use blue, velocity ratio, which is VR, velocity ratio equals to, now if you look at here, effort is below here as a denominator. Here the effort will be as the numerator. Okay, now here it is not just effort, we are going to say effort distance. Okay, just put distance now. Over, as you can see, the mechanical advantage here, the load was it was as a numerator. Then here we are going to say it will be now a denominator, but it's not effort, it's not load, but it will be load distance. So in simpler terms, what I'm saying here is, here for mechanical advantage, we just use load and effort, which is load measured in newtons, effort measured in newtons. But here you put distance, effort distance over load distance. So look at what we mean when we start calculating something. Okay, so these are the important things that you need to remember. And the last one is efficiency. So you're going to be asked only efficiency. Okay, so efficiency, again, we need to look at the formula. So remember that also velocity ratio doesn't contain what? Units. Since it is a ratio, no units. Okay, so efficiency now, efficiency, so efficiency, we are going to have mechanical advantage. So we're going to get this mechanical advantage divided by velocity ratio, then multiplied by what? 100%, because efficiency is always what can I say? It's always expressed as a what? A percentage. So if you find the mechanical advantage, then you find the velocity ratio. If you divide, make sure that you multiply by 100%. Okay. Now let us just look at one simple example. Okay, one simple example. Okay, so now let us apply our knowledge of mechanical advantage as well as velocity ratio under inclined plane. So this is the good example that we can have. Okay, so the question is saying the diagram below shows a 25 kg object being pushed upward by applying the 300 Newton force as shown below. Okay, this is the diagram that they are talking about. So they are saying this 25 kg object, as you can see, it is being pushed up by applying this force, which is 300 newtons, okay, along this distance, which is 5 meters, and this distance 4 meters, and this distance is 3 meters. Okay, now the first question is saying calculate the mechanical advantage. So remember again, remember what we said. Mechanical advantage, always remember the formula. How can you remember the formula? By simply saying MEL. Okay, let us answer this one by simply saying MEL. MEL, which simply means that M stands for mechanical advantage, which is MA, mechanical advantage equals to load over effort. Okay, then the only thing that is left is to identify the load and also the effort. So you come here, you put data here so that you can remember what we are saying. So what is the load here? What did I say the load? The load is the weight of an object. So you go to the object. If it has a certain force that is there, then basically you need to pick that load. Okay, you come back here. But they are saying this object is weighing about 25 kg. So meaning that we don't need these kilograms because load is measured in what? It is measured in newtons, which is in force. Okay, so now we're going to convert this 25 kg, which is the mass, into force. So how do you do that? Basically, you simply just multiply by 10. So you get this 25 kg, okay? Then multiply by what? 10 like that. Alright? Then if you multiply by 10, this 10 is what we call the force of gravity, okay? So you just get 25 and multiply by 10, then you're going to have 250 in the correct unit, which is the newtons. That's the first thing that you need to know. First, convert the mass that have been given, because we have been given the mass in kilograms. So convert that mass into what? Into the force. By simply just say 10 times 25. 10 times 25. 10 is coming from where? The force of gravity. Okay? Then next, we go to what? Effort. What is our effort? Remember that effort is what? The force applied to an object, which is 300 newtons, like that. Okay? Now after you do that, now you simply apply the data here. So the load, how much load do we have? We have 250. 250 newtons. Okay. How much effort do we have? It's 300 newtons, like that. Okay. Then if you divide this one, 250 over 300, we are going to use a calculator here. So I'm going to find out to say I'm going to have 0.83333. Okay. So this is the mechanical advantage that they need. So simply just round off to the nearest one decimal place so that you can have 0.8. And the other important aspect or important thing that you need to take note is you don't have to put the units at the end, because if you put the units at the end, that will be the wrong answer. Okay, so mechanical advantage does not have units according to what we discussed. So here this will be now our final answer, which is 0.8. all right, now we go to the next question. So the next question now is simply talking about, now since this is the mechanical advantage that we are solving, it's going to talk about to calculate the velocity ratio. Velocity ratio. Again, what did I say about the velocity ratio? So velocity ratio, now we're going to say velocity ratio. Remember, if you know the formula for mechanical advantage, so you're just simply going to swap the factors which are there, which is the load and effort. So here I'm going to say effort, but it is not just effort, it is effort distance, if you remember. Over here we're going to say load distance. Okay, then we're going to say velocity ratio now is nothing but equal to find out the effort distance and find out the load distance. So let us start with the effort distance. You come here. So you come where effort is. This is effort, okay? And it is going along which distance? 5 meters. So as you can see, effort distance, this is where the effort is what? Running or pushing an object from, okay? So this is what we call the effort distance. This longest distance, which is the hypotenuse. So this longest distance, this is what we call the effort distance. So on effort distance, we're going to put what? 5 meters, because this is where effort is what? Pushing an object from. Okay, this one. Now, the question that you can have is, now, how do you find the load distance? So load distance, now there are two distances that are here. There is the one for 4 meters and the one for 3 meters. So which one are we going to pick? So we always pick the vertical distance, this distance, always this distance. So let us use red, this one. Okay, we always pick the vertical distance, which is what? 4 meters for the load distance. Okay, always. If you get 3, basically your calculation will be wrong. So we're going to say 4 meters here. 4 meters. Okay. Then the velocity ratio would be nothing but equal to, if you divide the 2, you're going to get now 1.25. Then remember that the velocity ratio also doesn't contain units. Don't put units here, because velocity ratio is the what? It is the ratio. So that's why the answer would be like that. Okay, it would be like that. Velocity ratio is nothing but equal to 1.25. Mechanical advantage is nothing but equal to 0.8. The last question that they can ask you is this one, number 3. They are going to say calculate the efficiency. Okay, efficiency. So now, how do you calculate the efficiency? Remember the formula again. So under physics, if you forget the formula, basically you are not going to answer the question. So make sure that you practice on how you can be remembering formulas. So if you remember, we said efficiency is nothing but equal to, you get mechanical advantage, then divided by what? Velocity ratio multiplied by 100%. This is the formula for mechanical advantage, or I mean the efficiency. So then you say mechanical advantage. Do we have mechanical advantage? If you go back to the calculations, what was the mechanical advantage that we had? We had this one, 0.8. But basically, if you want to replace in the calculation, you need to get the one that you didn't round off. Okay, so we are going to get the 0.83 instead of getting the 0.8, because this one we rounded it off. But we are going to get the 0.833 because we didn't round it off. Okay, so we're going to get the 0.833. Reason being because we always get during the calculation the one that we haven't rounded off. Okay, then divided by velocity ratio. What was our velocity ratio? Which is basically 1.25, and we didn't round it off, the 1.25. So you say over 1.25. Okay, if you simply divide this one, you are going to have, then if you divide this one, then multiply by 100, you are going to have 66.6%. Okay, so that is the final answer for efficiency. So you are going to have 66.6%. And the question that they can ask you about this efficiency is that, why is this machine not working at 100% efficient? Because the answer here is 66.6%. Now they are asking you to tell them the reason why this machine has the efficiency of 6.6%. What could be your answer? So your answer that you can give there is because of what? It is because of some frictional force. Because if this is the machine that is working and you are pushing or pulling this object, basically you are creating the friction force between the two objects, the inclined plane and the object. So that friction force basically is going to generate heat, and that heat is in form of energy. So we are going to say it is because some energy are going to be lost out because of some frictional forces. So what are we saying here? So the reason why, instead of putting that question, why this machine is not 100% efficient, we are just going to put the reason here why this machine is working at 66.6%. We are saying due to what? Due to frictional forces. Due to frictional forces, okay? Due to frictional forces making making heat loss, okay, in form of energy. Okay, so that should be the reason why this machine is not working at 100% efficient. So you say it's because of some frictional forces making heat loss. Okay, so if there is frictional force, the result of that will be heat loss, and that heat loss will be in form of energy. So that machine is losing energy due to frictional forces. That should be the main reason. Okay, and this is where we end from, and make sure that you stay tuned. In the next video, we'll talk about the pulley system, on how you can go about the pulley system as well as the questions. All the best, start well, until next time.